Right. Shall we start? So we have 67 so far. So anyway, others will connecting while we are doing the lectures, right? So I hope that you might face some difficulties because that the time has changed, but nothing has to do because I have exam in the morning for the first year student, and I supervise that exam. So then I have no time to do the lecture in the morning. That's why I just want to change the time, and that exam was finished at close to 2 p.m. So then I have postponed the lecture to 5 today, and I thought to bring this lecture into Sunday, but some of the students have chartered exam. So therefore, suddenly I bring for the today 5 to 6 or 5 to 7, because the next week we also have some holidays, right? So then I just want to finish this topic. Right, shall we start? So far we have discussed smoothing techniques. Two smoothing techniques we have already discussed. First we discuss decomposing approaches, right? Two approaches, forecasting approaches. And next we discuss smoothing techniques, which is simple moving average and weighted moving average. So we had an issue at the last lecture because that the solo plugging is not working in my computer. I just tried to correct it today. I don't know whether it's all right or not. Sometimes it's works, sometimes it's not working, because this is a third-party software I'm using in this computer. So then sometimes that plugins it's all the plugins is not accurately work. We'll see how we can apply solver function for the weighted moving average. So I think you already have this table, and you have already calculated the absolute error and squared error and MAD and MSE. So then we are going to optimize the weights which can be get the minimum mean absolute deviation, right? Let's see how we can apply this solver function to minimize the MAD, because the lower the MAD, that means the lower the error. So then that our forecasting accuracy might be high. Right. Let's see how we can apply solver. So here I just reset, since I have already given the function. It's there. Let's see the objective, set the objective, which is I'm going to minimize the MAD. So then I select it, then minimized. Before that, we need to check whether that this has given the sum, but so here it's not given. Then I just need to give you the sum function over here. It should be 1, right? It just putting 1, it's not the function is working. Functions might not work if you just type it, but so therefore you have to give the function over here, right? So then
excuse me, sir.
Yes.
So is it correct? Square error.
Sorry.
Square error equation. I think F28 cell number F28.
Sorry. Which one?
F28 cell number.
F28.
I think.
What is it?
28, sir. Row number 28.
row number 28, yes.
Column F.
All right. Ah, yes,
There's
yes,
the one.
yes, that's it, that's true. Square error, yes.
No, okay, sir.
All right, yes. It's something mistake. Now it's all right, no? Right.
Yes,
Thank you for information. Right. Yes. Let's see. Yes. Because I made few changes, so then it automatically change. Right. Solve function is applicable. Then we are going to minimize by changing the weights, right? So then we are going to add some constraint. So constraints are these three weights should be less than or equal to 1, right? These three, any of these three weights should be less than to 1, less than or equal to 1. Then add. Then these three weights should be greater than or equal to 0, because it won't be 0. Any value greater than 0 should be assigned. Then sum of these function, sum of these weights should be equal to 1. Then okay. Right? So we have assigned the set the objective to minimize MAD by changing the weights. So we have given this constraint. Then we press solve. Right, it's work. Right, you can see that the weights has changed. Right, given weights has already changed with the solver function. If you want to keep the solver solution, then we can press OK. If you want to restore the originals, you can restore it by here this click on this tab, but we need to keep the solver function, and we can get the answer report. Just click on answer report, and then we can compare what are the previous weights and what are the given weights with the. So can you explain again, because some are not hearing, right? Am I clear for you? I think some may have the signal issues. I don't know whether all have all. How is the audio? Can you hear me?
Okay, audio is clear.
Yes, sir. Clear, sir.
Okay, right. Okay.
Sir, but the 2010 didn't have a filter data solo option.
In 2010, if you don't have the 2010 the solver, you can install it, right? So install. You can install it in Excel, that Windows. The file, then option, right? So you can go to the option. So here I can't see here in. Let me finish it and then tell you, right? Okay. Then you can see. So I will explain how you can install the solver. Now you can see that the MAD has reduced to 3.41. So I just generated answer report right here. Earlier we have MAD that is 2.61. Now it has changed to 2.31. Earlier that the original weights is 0.532 and new weights are 0.501 and 0.3, right? So yes, I will do it. right? So then you can see that the main absolute deviation, in the other way error has reduced, right? Right. Let me do it again. So before that, some in here Windows 2000, Microsoft Office 2019, it's here, Excel add-ins here, and you can add over here. But before version, that means Word 2010, it also there. Then option, you can go to the option, and there you can find add-ins, right? So just as my remember, so I have no here I can't open the window 2010. Then you can add this solver function, right? So option, then add-ins, add-ins. It's similar to this Excel add-ins, right? So then you can go solver add-ins, then press OK, right? Have you found the one student that asked from me? Did you found that solver?
I do, sir, but still there's a problem.
Can you share your screen? So I can allow you to share my, can you share? So this, some of the students have the same problem. So I just stop sharing. Can you share your screen? You are. Then click option, add-ins. Then here you can see solve add-ins. Yes, right. That's, then you have to press go below, not before, press select go. Excel add-ins, no, right, Excel add-ins, right? Then go, then press OK. Then you can select solver. Yes, then press OK. Now go to the data tab. It takes some time. The left corner, right corner, check whether that it's yes, it's installing. Don't press cancel. So if you cancel, that installation is stopped. Did you stop that?
No, sir.
All right, right. Yes, it's installing. It takes little, with the speed of your computer, little time. While installing, so tell me whether it's as installed or not. So I will again repeat the function, right?
Okay, sir.
I'll stop sharing. Right, so let me do it again. Some of the students have missed that part. So what I did is I just want to optimize the weights which can be minimize the MAD. So then just select MAD and go to the solver. Since I already have given the function, so I can reset it all or reset it all, right? Before that, so I have to change the change into earlier values, 0.5, 0.3, 0.2, and this should be sum. Yes, right. So remember that should be the sum function. Is that installed?
Yes, sir.
Now it's installed. Now it's there, no? Solver.
Yes, sir.
All right. Okay. All the students you can install in a Windows computer, right? And all the versions by going through the option, analytical analysis tool, and then solver, right? Right. Then solver, select the solver. Remember, you have to select minimize. Then by changing, you need to change all these cells, and you are going to add some constraint, right? Constraints are, first select these 3 weights, and it should be less than or equal to 1, right? It should be less than or equal to 1. It won't be greater than 1 because all total weight should be equal to 1, no? Then press add. Then again select these 3 weights. This should be greater than or equal to 0. Then press add. Then sum of these values should be equal to 1. Then we have given the 3 constraints. So these are the three constraint we should assign. Then press OK. Now you can see the constraints, and these are the cells we are going to change. And this is the objective cell. That means we are going to minimize MAD. Then we can press solver. Right. You can see that it has changed the weights. So we called it as optimum weights. We can assign to minimize the MAD. If you want to restore the results, so you can just click on and press OK. But you can see that MAD has reduced, so then we keep the solution. Further, we can get the answer report. So that is important to see what are the changes changes have taken place, right? So then press OK. Right. So then if you see the answer report again, so because I have 2 answer report, I have already generated one. So I just deleted previous one. Then here is the answer report. So you can see that this is just for information, right? This is just for information. You can see original and the proposed value, and proposed weights are given. Right. So then this is how we can minimize the MAD, and we can forecast the day 25 with the forecast weights, right? We just drag it down. Right? This is the forecasted milk production for the day 21. So let's see that forecasted values taken into a scatter plot. We just had, hopefully you are much familiar with this. X values, that is days. Y values, that's this should be start from the here, right? Otherwise then press OK. Right, these are the, so you can see that the line has moved, this one, right? That the fluctuations has reduced. So then we just had the forecasted sales for the day 21, day 21 milk production. X, that is last two, we select just last two. Y, just last two. Right? Then press OK. Here you can see so it follows the same pattern, right? It smooth the line. No, not actually, it follows the same pattern, but you can see that the line has moved, and the next day that the sales is, if you select this point, that you can see day 21, 59.39. Right. This is how we can apply the weighted moving average, right? So very short period forecasting we are using for the very short periods, right? If they don't have trend or seasonal components, right? So that seasonal fluctuations and trend component is not expected in this moving average. So solve එකට දැම්මම reduce වෙලා එන්නේ නැහැ, increase වෙලා එන්නේ. So if it is increase, select whether you have select the minimum. So here you can see data solver. Here you have to select minimum. It's by default it select maximum, right? So let's see what happens if it is select maximum. See, it's maximize, and so if you, its MAD become 104. Let's see how is the weights. That see, it's 1. Right, here it should be some. this should be minimum. Then it has changed. Check whether you have selected the minimum tab, right? Otherwise it maximized. Right. So that's all about weighted moving average. So then let's move to the next exponential smoothing, right? So here I think that the function has given determining better the weight set of weights. In the handout you have given, the constraint is also given. You can practice it. Let's take single exponential smoothing, right? This is another technique we are using to forecast the data. Here it's explained exponential smoothing is very popular scheme to produce the smooth time series. Exponential smoothing assigning exponentially decreased weight as the observations get older, right? In other words, recent observations are given relatively more weights in the forecasting than the older observation, right? This is here we are assigning a weight, right? We have taken the alpha value. It's kind of a weight we are assigning for the most recent observation, right? So normally this exponential smoothing is used as usually that if there is no trend and no seasonal fluctuations, right? Exponential smoothing is applicable if the data is with no trend and no seasonal fluctuations, right? So because we are using for the short-term period forecasting, right? Further, it also apply with the we call it as data with random variations, right? So have you ever heard the random variations? The data with the random variations, or else we call it as the irregular variations. Irregular variations, data with the random variations. For example, if I say, so if you are taking, so if you are travel work to home to workplace, if you take 20 minutes daily, the average time you take travel from your home to workplace is 20 minutes, right? Then it's the same distance, right? Assume that it's the 10 kilometers. So it takes 10 kilometers in the sense, not 10 kilometers, 2 kilometers. So it takes half an hour, right? That is the average time you have taken. But this time has depend based on the whatever the traffic conditions, right? Then what you use, which traveling mode you are using, right? Basically different unexpected things can be happen to change this time, but the distance is same and the average time you are taking is the same, but it may be vary with some irregular reasons. For example, here the traffic, based on the traffic, that it may take 2 hours, but the same distance, same if you are using the same if you use the bus, so you have just taken half an hour, right? But it may vary with the different unexpected reason. So these are called irregular variations. These are, if you take such observations, so then it has the irregular observations. So then this smoothing techniques is applicable for such data, right? So then here we also assign a weight, which called it as alpha. So the alpha is kind of a weight we are assigning. And so here we also assign the weight the more weight for the most recent observation. And if the observations are getting older, so we are assigning a lower weight, right? So this is what the single exponential smoothing. Remember, it's applicable if there is no trend and no seasonal fluctuation, and it's applicable for data with random variations, right? It's applicable with the data with the random variations or else irregular variations. And it also used for the short-term forecasting, right? As we use for the weighted moving average, right? So we are not apply for the long-term forecasting, which is earlier we applied the multiplicative and additive. The single exponential smoothing is also used for the short-term forecasting. Right. Let's see how we can practice it. So here you have the same example I have taken because yes, right. So here you can see the calculation part. Let's see with the Excel. Let's use Excel sheet and practice it. Right. You can copy the same data into a new sheet and we'll practice it. Here the single exponential smoothing, that milk productions 1 to 20. We have observed the same data. So you can copy from the previous sheet the same data, right? Right here. Let's copy the same data into a new sheet, and here you can see the alpha. Use alpha value. It's also a weight we assigned for the observation. Please copy this data. Have you finished? It's nothing. I think it's just copy the same data, no? Right. So here you have the data for the 20 period, 20 days and milk production. As usually, we derive the scatter plot, right? Insert scatter plot. You can see there is no seasonal and trend component, right? So trend behavior, there is no trend and there is no seasonal fluctuations, right? So then we can apply the single exponential smoothing technique, right? Remember this, the applicable of any smoothing techniques is depend on the behavior of the data, right? So in single exponential smoothing, we apply data with the random variations and short term as well as with no trend and seasonal fluctuations, right? Then we are going to forecast. Let's see how we can forecast it, right? Here, this is general explanation on forecasting. Y hat I, so normally we call it as y hat I plus 1 and alpha yi plus 1 minus alpha y hat 1 I, right? So here it says forecast the next period, forecast for the period smoothing constant error of this period, right? So this is the function we are going to apply, right? So the y hat plus 1, y hat I plus alpha, y hat I, y hat I is entered the Excel formula, right? Since this is something technical formula, I just change into some verbal formula, right? So I just change into wordings, right? This is how you can apply this, how you can forecast based on the single exponential smoothing. Forecasted value can be calculated alpha multiply by, please somewhere else, I think it's not included in the handout, it's included the technical formula. So, but you might get confused. So therefore I just add the this something more familiar with you. Alpha multiply by actual data for the previous time period plus 1 minus alpha multiply by previous forecast data, right? Please write down this somewhere else. Forecast alpha multiplied by actual data for previous time period plus 1 minus alpha multiplied by previous forecast data. Right, let's apply this formula. For the first period, we just copy the same value from the corresponding period, right? That is 56.56. Then we're starting the formula from the next period because we have to have a forecast, previous forecast data, right? So let's apply this formula. Before that, I just use alpha and here I just repeated this alpha value over here, right? Yeah, this is the alpha. This is pre-assumption, right? So normally the alpha is in between 0 to 1. 0 to 1. We assign a value, any value between 0 to 1. And then we optimize it, right? So therefore, normally we assign closer value to 0, right? So then 0.5, we assign the 0.5, then we can optimize it, right? Let's use the function, which is alpha, right? Let's use alpha, right? This should be fixed because it won't be changed over the period. Multiplied by actual data for previous time period, right? Actual data for the previous time period. What is it? Which is B6, right? Actual data for the previous time. This is actual, this is forecast, right? Then plus the formula is open bracket 1 minus alpha, that is alpha should be again fix it, right? Again fix it. Then what is it? Multiplied by previous forecast data. Previous forecast data. Sorry. Multiply by, so multiply by previous forecast data, right? Then press enter, right? This is the formula, which we has already given here, right? Alpha multiplied by the actual data for the previous time period plus 1 minus alpha multiplied by previous forecast. This is the formula, same formula, right? Here, for the next period, y hat I plus 1 in the sense next period, right? Then alpha multiplied by the y I plus 1 minus alpha y hat I, right? Let's see. So then we just drag it down. Right. Remember the formula, right? So alpha multiplied by actual data for previous time period plus 1 minus alpha multiplied by the forecast, previous forecast data. These are technical formulas, right? Then we can calculate the absolute error. Absolute error. It's difference between the actual and the forecast. What we already did, already practiced it. Then square root of error. we can either square this or we can get the difference and square it. Let's take the difference, because if we mistake somewhere, if we done any mistake, so it's also applicable. So therefore, it's better to get the data from the original source. Then we can calculate MAD and mean square of error. MAD, average of the absolute error, and MSE in the sense average of squared of error. Right? This is single exponential smoothing. So here I can just copy this into here. Suitable for no trend season, no trend and seasonal data, and short-term forecasting. Right. So then, as usually, we can decide the beta alpha, right, by using solver. Same as we apply the weighted moving average, we can use solver function to decide the most accurate alpha value, right? Initially, we assume whatever the value between 0 to 1, then we can forecast based on the solver function in Excel, right? So we are going to minimize MAD, then data, apply solver, right? We are going to minimize MAD 0.71 by change this alpha value, and we can add some constraint. This alpha value should be less than or equal to 1, or this alpha value should be greater than or equal to 0. Then we can solve.
Sir,
Yes.
that would be maximum or minimum, sir? Solver.
Yes. Yes, minimum. So that's, I made the mistake, same mistake. Cancel it. Solver, yes, that should be minimum. Otherwise, it automatically comes 1. Then solve. Yes. You can see that it has reduced to alpha. The correct alpha is 0.3, and the MAD has already reduced. So let's generate the answer report. So then press OK. Then here the answer report is this. This one. No? Right. See 0.63 and answer report is here. Right. 0.71 earlier, 2.63, and the original alpha is 0.4, and after rearrange it, after using the solver, it has reduced to 0.3. That is the correct alpha we should assign. Right. Then based on this, based on the alpha, we can forecast the next data point. Right, this is the forecast. 51.1 chat question is there. What is it? So can you explain it again? Yes, sure. Let me take this function. Yeah, this is, I think, much clear for you. So suitable for, this is what random variation, no trend and short term, and this is how you can calculate the forecast, right? Any question? So we'll add the forecast values. X values, sorry. So this one. Let's draw it, day 21. See, that is forecasted, and we can just add the day 21 milk production, X class 2 and last 2 forecasts. Then press OK. Right, this is, you can format this chart. You can add what? Right. So you can modify this chart area. You can name axis, right? I think that is basic things, basic Excel function, right? Chart design, right? Format. Right. Somewhere it's available that you can add some information into this chart, right? Right. Right. This is single exponential smoothing. Remember, we need to optimize this solution. Otherwise, it won't be the correct alpha. So because earlier we used the 0.4, right here for you don't need to keep it or older one, right? This is for information. I just want to show you what the earlier alpha and what would be the alpha which we can obtain after using the solver, right? This is actually not needed, this part, right? So then this is the forecasted sales, forecasted milk production, right, for day 21, right? Any question? Here, I think the solutions are given. Right here, you can see that 0.31, same one. This is how you can optimize it, right? Right. Then we'll move to the double exponential smoothing, right? Hall's model, Hall's method. So if you want to I just keep it for a few minutes. If you want to copy the formula, so these are the formulas we used, right? So you can see formulas. This is how that we use the functions. We take this alpha and trace dependence, trace, right? So there are some functions in Excel. You can practice it. Right. Then we'll move to the double exponential smoothing. It's called exponential on exponential smoothing, right? So we are doing the smoothing techniques twice, right? Double exponential smoothing defined as exponential smoothing of exponential smoothing, right? So we are apply 2 times of this smoothing techniques, right? And this method works best when the time series has a positive and negative trend. This is how it differs from the single exponential smoothing. Earlier we apply if there is no trend, but if there is a trend or positive or negative, so then we can use this double exponential smoothing, right? So we use the trend and then we forecast. Based on the trend, we can forecast, right? We'll see. With the time constraint, I will directly move to the example. Here we use alpha and beta both, right? So we use alpha and beta values. Earlier we used alpha in single exponential smoothing. Here we use alpha and beta, right? So while we use it, you will be able to understand it, right? So here general explanations. Right, you might confuse with these formulas. Let me practice it. Right, here you have to copy this data. Let me change it. alpha and beta value, right? Please copy this information. Please copy this information into your Excel worksheet, and then we can practice it, right? Hope you finished. Please raise your hand if you finished. Yes, I think it's students are raising. Right, then this is how we can apply. To use the method, calculate the base level, right? The base value EI for the time, and then compute the expected trend value, right? We are going to calculate the base value as well as the trend value. These are the two formulas we are going to apply to calculate the base value and the trend value. E in the sense, EI in the sense base value, alpha yi plus 1 minus alpha I EI minus 1 plus TI minus 1, right? So then trend we can calculate based on the beta, right? So this is the formula, EI minus EI minus 1 plus 1 minus beta and TI minus 1, right? This alpha and beta should be within 1, right? 0 to 1. So that is what it mentioned. We are going to calculate the base value as well as the trend value. Then we forecast based on the base value and the trend value, right? Let me this is how you can calculate the base value. That technical formula I just convert into wordings. Alpha, actual data for the previous time period, plus 1 minus alpha multiplied by previous forecast data plus previous trend, right? So you can write somewhere else, base calculating, right? Let's calculate it, right? This is the formula. First, as usually the same actual data we copy for the base value, right? From second observation, we are starting the formula because we need to have a previous base value, right? Right. So then we can apply this formula base value, right? Starting from the formula alpha, right? Alpha is 0.3, right? Alpha, right? Then we can fix it. Right? Actual data for previous period. Actual data for the previous period. In the sense here, multiply by, right? Actual data for the previous period plus 1 minus alpha. That is the difference between 1 minus alpha. That should be also fixed. Right? This is 1 minus alpha plus 1 minus alpha. That is 0.7. Multiply by previous forecast data. Previous forecast data. Right? Previous forecast data. We should put it in bracket, otherwise it will not correct formula. It won't be a correct formula. So open bracket, previous forecast data right? Then plus trend, previous trend. Here that when we fill this value, it automatically taken. Until it's filled, we just give the formula, right? Right? This assign with this formula, then press enter. And double click on it. Right? Have we finished? Base value. This should be actual data for the current period, right? This one. Right, actual data for the current period. Right, then calculate the trend value, right? Then we can calculate the trend. So we start in the trend from the zero, right? As usually it's starting from the zero. And we can give the formula for the trend function, right? That is beta multiplied by, let's assign the function beta. For the trend function, we use beta. For the base function, we use alpha. Beta, that should be fixed. Then multiply by, open bracket, right? Here, current base value, right? Current base value, that is C6 minus previous base value. Previous base value, then close the bracket, plus, right, plus 1 minus beta, right? 1 minus beta, 1 minus beta, not alpha, beta, right? Close the bracket, multiply by previous trend. Previous trend. Then press enter. Then we can drag it down. Right, so yes, I'll do it. right? Let me check, something went wrong. Yes, so trend value එක අපේ Excel එකෙන් ආපු එකට සමාන නැහැ. Right, we'll see. All right, again, we'll check the formulas. Right. Yes, one chat question. The alpha value add එකයි මම alpha value add right. Let me check it. Let's practice again. So see what we did is base value, alpha, that should be fixed, right? Multiply by actual data for the current period, right? Plus 1 minus alpha, that should be fixed. Close the bracket. Multiply by previous forecast data right, previous base value plus previous trend. Right, then we'll see after calculating the trend component, right? Trend component beta right, right, beta multiplied by current base value minus previous base value plus 1 minus beta. That should be fixed. Close bracket. Multiply by previous trend. Then press enter. Right. Have you received the same values?
Yes.
Right, okay. Now this is the trend component, right? Base value and the trend value. This is this should be actual data for the current period. Current period. Previous base value. Yeah, the formula should be changed, right? Actual data for the current period plus 1 minus alpha. Right. Then forecast forecast in the sense base value plus trend component. So forecast is here. We should start from the previous, right? Trend is for the first period is 0. Right, the forecast is starting from previous, right? Previous base value plus the trend component, trend value. Then press OK. Press double click. So be careful when you apply the formula, right? So then here the correct formula is there. Right? Be careful when you apply the formula. So let me bring this formula. Right. Let me copy this into Right. These are the two formulas we applied. Then let's draw the. So before start these steps, we need to derive whether it has followed the given what we call given format, right? So we have given the instruction, if you need to follow the double exponential smoothing, there should be upward or downward trend. So before I apply this function, before I apply this method, we need to know whether that the existing time series has a upward or downward trend. So then we need to insert, we need to derive the scatter plot, right? So here, it is the first step which I missed. So you can see that it has an upward trend. So then we can apply this double exponential smoothing. Absolute error is same as earlier, right? Absolute error, ABS, right? Absolute error, actual, and the difference between the actual and the forecasted. Here the actual value minus forecast. Right, forecast. So this is the absolute error, right? Then square root of error, we can get the difference and get the square root value. Actual minus right, actual minus forecast to then we can get the MAD, average of absolute square of error. That is 171. Then square root of error, average close the bracket. That is 42,306. Right. So remember, be careful when you apply the formula, this calculating the base value and the trend value, right? So here, these two functions are applicable. Now it's all right, that 171 and 43,212. Right? Yes, chat question. So absolute error again to it. Absolute error, it's nothing what we already practice. Absolute error is calculated equal ABS, absolute error ABS, right? Absolute error, we don't worry about absolute error in the sense we don't worry about whether it's plus or minus. That is actual value. This is the actual value, corresponding actual value minus, this is the forecast. This is the forecast, right? Then press enter. Then we can bring this into our chart, right? Select data. Forecast, we can add forecast sales. Select data. We can add this is forecast X values starting from 2 then Y is forecasted sales. Forecasted sales. You can see that the line has moved. That is why we call it as smoothing techniques. අපි මේ line එක smooth fluctuations අඩු කරලා තමයි ඊළඟ level එක predict කරන්නේ. So we are going to predict the day, month 25th month, right? 24th, 25th month sales, right? Then we can optimize this alpha and beta. This is the last step on double exponential smoothing, right? We can optimize it, right? We can optimize it. How we can optimize it? We need to minimize the MAD. So then data solver. So I reset it, minimize it, right? These two, right? Minimize by changing the cells, these two, alpha and beta, add some constraint. This alpha should be less than or equal to 1, right? Add again, this alpha should be greater than or equal to 1, greater than or equal to 0. Add beta less than or equal to 1. Add beta greater than or equal to 0. So we need to add 4 constraints for these two, alpha and beta. Alpha and beta. Then we can solve it. Alpha becomes 0.1 and beta become 1, right? We can keep the solver solution, then press OK. Right. Right. You can see that the original value and the 1.171 and 140 is after change the alpha and beta, it become 140. Right. 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 This is about double exponential smoothing. So you can see that these all the functions and everything is given in the handout. You can practice it. Since the time has passed, I just finished from here, and this is the last topic on last area and I want to discuss on time series analysis. So anyway, I will upload this completed practical activity, and the recordings will also uploaded. You can go through it and then practice it. Remember, in the exam, I think you will be given a physical exam based on current situation. So therefore, you need to practice it, these examples. So then you will be able to get some understanding, right? Right. So with that, I just stop from here, and we'll meet. I think next week. I have no idea who is going to do the lectures and how is going to conduct, because that some holidays are coming. We'll let you know. Right. Thank you very much for a sudden message. You join one chat question. What is it? So Wednesday, the mid exam. Most probably the mid exam will be conducted on Wednesday, right? We'll let you know by, we'll inform you tomorrow, or else I will put the message. I will discuss with Nishant and let you know by today itself, evening, in night. I just uploaded the time. Sir, Wednesday we have strategic forum. Okay, let you know, I have no idea. So when you are going to have your mid exam, I'll discuss with Nishant, because he is the person who are going to conduct this mid exam. I will discuss, and I will also pass that this strategic forum and whatever you have, that extra activity. Let you know, right? So if you have any concerns, please inform to Nishant, sir, right? Right. Thank you very much for joining with sudden message, and we'll meet with another topic, that is portfolio. So for the until we next time, thank you very much. Thank you very much for joining. Right. Thank you.
Thank you, sir.
Thank you, sir.
Okay.